All right, we're switching gears. We're moving on to Unit 10. Pardon me. Yikes. Okay, so Unit 10 is all about trigonometry. So we're going to start off with some stuff that hopefully you remember from last year in geometry. So first thing, just pause and take a moment and think about what you remember about these words sine, cosine, and tangent. Now, I'm going to go out on a limb and say you might remember something called SOHCAHTOA. What SOHCAHTOA stands for is the first three letters, SOH, is sine equals opposite over hypotenuse. Now, those are fancy words, but opposite of what? And what the heck is a hypotenuse? So let's talk about the context for this. We are talking about the right triangle. On a right triangle, if you were to use some angle, let's refer to like that angle, and I'm going to use this symbol here. We'll talk about that symbol more in a second. If that's the angle we're focusing on, the side that it's not touching is the opposite side. Now, the longest side of a right triangle is always your hypotenuse. And then the other side that's not the hypotenuse, but it's touching that angle, we'll call it a leg, is the adjacent side. So the sine equals the opposite divided by the hypotenuse. The length of the opposite divided by the length of the hypotenuse side. Cosine is the adjacent side divided by the hypotenuse. And tangent, finally, is the opposite side divided by the adjacent side length. So sine opposite over hypotenuse. C-A-H, cosine equals adjacent over hypotenuse. TOA, T-O-A, tangent equals opposite over adjacent. Hopefully that rings a bell. We're going to work with those in just a little bit more. So a couple things we're going to do today. We're going to first remember and relearn what SOHCAHTOA is. We just talked about that. We're going to talk about the properties of 30, 60, 90 triangles and 45, 45, 90 triangles and talk about how they're related to the sine, cosine, and tangent. And we're also going to talk about these things that are called cosecant, secant, and cotangent. You might not remember those. I don't even know if you've learned those, to be honest. And we're going to relate those to SOHCAHTOA. So let's jump right in and just refresh and dig a little deeper on sine, cosine, and tangent. So the sine of some angle, and again, that symbol there is the Greek letter theta. So the sine of an angle theta is the ratio of the length of the opposite leg to the length of the hypotenuse. So in this triangle here, the opposite side would be 4, the hypotenuse would be 5, so it's 4 over 5 for the sine. The cosine is the adjacent over hypotenuse, the adjacent being 3, hypotenuse being 5. And the tangent is the ratio of the opposite leg to the adjacent leg. So the opposite leg, 4 over the 3. So again, those three equations off to the right here. Same thing we talked about in the previous on the warm-up. Sine equals opposite over hypotenuse. Pardon me. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Let's try this out. I'm going to give you a right triangle, and we're going to talk about the sine, cosine, and tangent of that angle. So on this triangle, we've got side lengths 7, 24, and 25. And our angle theta is here, which means we're focusing on that side there. So when you're thinking about this, it's probably helpful to label what's opposite, what's adjacent, and what's the hypotenuse. So the opposite side, again, is the only side that angle is not touching. We call that the opposite leg. The 24 is the leg that it is touching, so we're going to call that the adjacent side. The 25 is the hypotenuse. So sine is opposite over hypotenuse. It's 7 divided by 25. That's it. Cosine, adjacent, 24 over hypotenuse, 25. That's it. And then tangent, opposite, 7 over adjacent, 24. Now again, whenever you're dealing with fractions, always be sure to reduce if you can. If you can't, then, well, you can't, so don't bother reducing. Take a few moments, pause the video, try out example 2. You've got an angle there. I would say label opposite, adjacent, hypotenuse. Set up your fractions. If you can reduce, do it. And let's all pretend that you paused the video. So here's our triangle. Here's our angle measure. That means 30 is our opposite. 16 is our adjacent. And 34 is your hypotenuse. Again, hypotenuse is always the longest side. It's always the side that's not touching that right angle. The sine, opposite, 30 over hypotenuse, 34. 30 over 34 is reducible. They're both divisible by 2. We can make it 15 over 17. Cosine, adjacent, 17 over hypotenuse, goodness gracious, sorry, 16, my goodness, over the hypotenuse, 34. Both of those are divisible by 2, which gives us 8 over 17. The tangent, the opposite side is 30. The adjacent side is 16. Reduce those both dividing by 2, we get 15 over 8. So make sure you're labeling adjacent, opposite, and hypotenuse. Make sure you're setting up your fractions. Make sure you're reducing as needed.